Moving on to question 5 of paper 2 of June 2024. 5.1. If sine 40 degrees is equal to p, write each of the following in terms of p. 5.1.1. We have sine of 220 degrees. So we know that that's an angle in the third quadrant. So we can rewrite 220 degrees as sine of 180 degrees plus 40 degrees. Now we also know that in the third quadrant, that sine would be negative. So when I reduce this to an acute angle, I have negative sine of 40 degrees. So sine of 220 degrees is equal to negative sine of 40 degrees. Now in the question they said sine of 40 is equals to p. Therefore, the sine of 220 degrees is equal to negative p. 5.1.2. Cos squared of 50 degrees. So what I notice is that I have the cosine of 50 degrees, but they gave me the sine of 40 degrees. Now can you see that these two angles add up to 90 degrees, so they are complementary angles. So I can use the co-function. So we have the cos of 50 degrees squared, and that is equals to the sine of 40 degrees squared. So remember that the cosine of 50 degrees can be written as the cos of 90 minus 40 degrees. And we change cosine to sine when we have 90 minus. So now we have this expression in terms of sine of 40 degrees, and sine of 40 is equals to p. Therefore, cos squared of 50 is equal to p squared. So I simply replace the sine of 40 with a p, and that answer is p squared. 5.1.3. The cos of minus 80. So before I try to manipulate the 80 degrees, I'll take care of the minus in front of the 80 degrees. So cos of a negative angle places me in the fourth quadrant. That means that the cosine of negative 80 degrees can be written as positive cos of 80 degrees, because cosine of a negative angle would be positive in the fourth quadrant. Then I notice that 80 degrees is twice the size of 40 degrees. So we can rewrite 80 as 2 times 40 degrees. And that is a double angle. So we can use our formula sheet, and remember, for a double angle for cosine, we have 3 options. And one of the options has sine in it. So I can rewrite the cosine of 80 as 1 minus 2 sine squared of 40 degrees. Now we have 1 minus 2 with the sine of 40 squared, and that becomes 1 minus 2p squared. 5.2. Given tan x multiplied with 1 minus cos squared x plus cos squared x is equals to sin x plus cos x multiplied with 1 minus sin x cos x divided by cos x. 5.2.1. Prove the identity. So when we prove the identity, we need to prove the left-hand side equal to the right-hand side. So I'm choosing to do the left-hand side first. So we have tan x multiplied with 1 minus cos squared x plus cos squared x. So you would need to know that tan x can be written as sin x over cos x. And I also noticed that 1 minus cos squared x is simply sin squared x. And that comes from sin squared plus cos squared equal to 1. So if I move the cosine to the right-hand side, I have sin squared is equals to 1 minus cos squared x. So in my very first step, I'll rewrite tan as sin x over cos x. And I'm going to rewrite 1 minus cos squared x as sin squared x. and I need to add cos square x. Now can you see in our first term, we already have the denominator of cos x, which we need to prove on the right-hand side. Now for the second term, I also need to create the denominator of cos x. And what we need to do in the second term is we need to multiply both the numerator and denominator with cos x. In the numerator, it will become cos cubed x, and in the denominator, we'll have cos x. So the first term is sine x multiplied with sine squared x. So that becomes sine cubed x over cos x. And in the second term, we have cos cubed x over cos x. Now our denominators are the same. So in the numerator, we have sine cubed x plus cos cubed x over cos x. So if I compare it to my right-hand side, I have my denominator. And what I need to do now is find a way to rewrite sine cubed x plus cos cubed x in the form of brackets. So in grade 10, we learned how to factorize a sum of two cubes. So in the first bracket, we'll have sine x plus cos x. And in the second bracket, we'll have sine squared x minus sine x cos x plus cos squared x. And this is all over cos x. So let me quickly remind you how we factorize a sum of cubes. In our first bracket, we take sine x plus cos x without the exponents. Then in our second bracket, our first term would be sine squared x because we already split or took out one sine x. And our very last term would be cos squared x because we already have a cos x in our first bracket. Remember that the last term in this bracket will always be positive. Now for the middle term, I multiply the terms in the first bracket and I change the sign. So this is a positive multiplied by a positive, and that is sine x times cos x, and I change the result to a negative result. Now if I compare it to my right-hand side, can you see it is pretty close? And all that I need to do now is add sine squared with cos squared, and that is equal to 1. So we have sine x plus cos x multiplied with 1 minus sine x times cos x over the cosine of x, and that is the right-hand side. 5.2.2. For which values of x in the interval of x between negative 180 degrees to 180 degrees will the identity be undefined? So notice they said the identity needs to be undefined. So on the left-hand side, I know the identity will be undefined for the asymptotes of x. And on the right-hand side, the fraction would be undefined if cos x is equal to 0. So first, we would say for tan x, the identity is undefined at the asymptotes of tan x. So that is x equals to 90 degrees plus k times 180 degrees. So what I'm doing now is I'm just writing down the general term for which the identity would be undefined. But there is a restriction here. So I need to choose values of x between negative 180 degrees and 180 degrees. So for tan x, that will be at negative 90 degrees and 90 degrees. So all that I'm doing is I'm substituting k with negative 1, and that becomes negative 90 degrees. Then I'm substituting k with 0, and that becomes 90 degrees. And if I substitute k with 1, it is 270 degrees, but that's outside of that range. And we said on the right-hand side, we need to make cos x equal to 0. So if we make cos x equal to 0, if you remember from the cosine graph, cos is 0 at 90 degrees as well. So that will be for x at 90 degrees plus k times 360. So that's my general solution. But a specific solution then for cos would be where x is 90 degrees. And the reason why we only have 90 degrees here is because when k is negative 1, I'm at negative 270 degrees. And when k is 1, I'm at 450 degrees, which is both outside of that range. So when k is 0, we have the 90 degrees. So therefore, the identity is undefined for values of x of minus 90 degrees and 90 degrees. But in your solution, you need to show that you're considering tan of x and cos of x equal to 0, even though they produce the same results. Given the expression sine 150 degrees plus cos squared x minus 1 divided by 2, 5.3.1. Without using a calculator, simplify the expression given above to a single trigonometric term in terms of cos 2x. So they are saying that the result of simplifying this fraction would be in terms of cos 2x. It is not saying it is equal to cos 2x, it says in terms of, and that means that cos 2x is part of the solution. So if I look at the fraction, the first thing that I notice is that I have a common denominator or a single term in my denominator, and I have 3 terms here. So for me, it is natural to break up that fraction into 3 terms, where every term has a denominator of 2. And what I can see now is I have 3 terms that I can try and simplify. So let us start with sine of 150 degrees. That will be sine of 30 degrees divided by 2. So remember that sine of 150 degrees can be rewritten as the sine of 180 degrees minus 30 degrees. And that places me in the second quadrant. And we know that sine is positive in that quadrant. So we can reduce 150 to 30 degrees. Then for the next 2 terms, I'll keep the fractions as they are because there's nothing to do. Then I know that sine of 30 degrees is equal to 1/2. So it's important, the question said without the use of a calculator. So when you simplify, you can't go from 150 directly to 1/2. You first need to show that 150 is a special angle or it reduces to 30 degrees, and then that sine of 30 is equals to 1/2 plus cos squared x over 2 minus 1/2. Now, if you rewrite a half divided by a half, it will become 1/4 plus cos squared x divided by 2 minus 1 divided by 2. And what I want to do is create the same denominator again. So the second term, I'll multiply by 2 at the top and the bottom. And the third term, I'll also multiply by 2 at the top and the bottom to create a common denominator of 4. So when I put it all back together, I have 1 plus 2 cos squared x minus 2 over 4. And if I add like terms together, I have 2 cos squared x minus 1 over 4. And from the formula sheet, we know that cos squared x minus 1 is equals to cos 2x, and we divide that by 4. So can you see that the question said in terms of cos 2x, and my final result has cos 2x in it. 5.3.2. Hence, determine the general solution of our fraction equal to 1 over 25. So in the previous question, we found that that fraction can simplify to cos 2x divided by 4. So when they say hence, it means use your solution from your previous question. So we have cos of 2x divided by 4 is equal to 1 over 25. And if I multiply out, I have cos 2x is equals to 4 over 25. So I'm just multiplying the right-hand side with the denominator of 4. Next, I'll find my reference angle. And now you can use your calculator because we need to find the general solution. So the reference angle would be 80.79 degrees. And we know that cos is positive in quadrant 1 and quadrant 4. So for cos 2x, we'll have two solutions, one for quadrant 1 and one for quadrant 4. So we have 2x is equal to 80.79 degrees plus k times 360. And we divide everywhere by 2, and that becomes 40.4 degrees plus k times 180, where k is an element of integers. For quadrant 4, we have 2x is equal to 360 degrees minus 80.79 degrees plus k times 360. And when I divide everywhere by 2, that simplifies to 139.6 degrees plus k times 180, where k is an element of z, or an integer. So that's one way of doing it. The other way is you could have used, from this point on, the graphical method. So for the graphical method, we would say 2x is equals to plus minus 80.79 degrees plus k times 360. And then we'll divide everywhere by x. So x is equals to plus minus 40.4 degrees plus k times 180 degrees, where k is an integer. Thank you for watching. Remember to show your support by hitting the like button and subscribing to Mathenatic.